Answer, I had general doubt.
Yeah.
So in automotive, we used to have standard tools like vector can or other things for testing.
Hmm.
Whereas in embedded domain, how do they will test all the SPI, UART, I2C, this kind of protocols?
Thank you. Actually, it was a little bit tricky only in the initial phase. They have a because every microcontroller has specific architecture. For that, they have data sheet, those sort of things. To avoid that only, they have come up with a common standard now. I believe you heard about it, AutoSAR. Have you heard about AutoSAR?
Yes, answer.
So in AutoSAR, if you just use the stacks, for example, there is an IO stack. If you use that, using the stack, that stack is available for all microcontroller that we have in the market. That is widely used in automotive industry. So they no need to know these granular details as we are exploring. Actually, this is needed to understand a product perfectly. You should know the data sheet. But when you don't have time and don't have time to invest to read data sheet and all, now they come up with this AutoSAR. Using that, you no need to study these things. Only you make the selections. Already the codes are written and made it available in a generic way. For
My doubt.
example, if I provide you a generic program for timer 2 module, you will just use it and will optimize it according to your need. So you won't write a program for timer 2 by yourself completely right now. It's just like a library. So library, they have come up with this standard. Those standards will help them and to without knowing the exact architecture, they can design the software. That is one thing. And how to test them. To test these autos are implemented module also, they have lot of other tools are available. In uh, microcontroller automotive development itself, they have something called a lauter bag or those sort of things. Using them also, we can perform test, development related test on universal controllers. Like for many controllers, they support uh, using them, we can perform the test. For development related testing, yes, we have a tools. Previously, it was specific to chip manufacturers. Let us say if I use microchip uh, based controller, I will use the MPLAB IDE and related debuggers associated testing tools available from the microchip. If it is a free scale one, they will use their own debugger and then their software tools. Those are available. Previously, it was specific to microcontroller manufacturer. Slowly, the automotive industry is standardizing even that too. So they will have a simple architecture. In that, the libraries will be available. People will simply select and use it, and they have a testing platform as well to test them whether it is implemented perfectly or not.
So I have no doubt. So if an embedded tester role, what they will usually test, sorry. So developer used to do his basic testing.
Developer will also use canalizer. Have you heard about canalizer?
Yeah, this question is regarding from the embedded domain point of view. In automotive, an idea.
Okay.
So in embedded domain, so already the developer will do all the SPI testing, UR testing, CAN testing. So he used to do with the debuggers and those things.
Okay.
So if we release that, how the testers will test it? In automotive, we used to have Keno tool
Okay. You
and
mean to say
other.
general embedded system?
Yeah, general embedded systems.
Yes. They will do the manual testing. If there are many manual testing methods are available, they can use that. They can use Python, C Sharp, but most of them were customized test automation tool. There is no, from my view, for embedded module testing, that is hardware module testing, there is no a specific universal tool. See, for example, all embedded system can be tested with this tool. Like that, we don't have. They will have a customized tool specific to the product.
Okay. If if they use Python, how they used to do, sorry. So
Brilliant. Super. Right. The Python has library for, let's say, your is a non-automotive one, and you have to test some HMI. Your your product, embedded product, has a display in that. For example, if there is a call received, it will display the call is that means that mobile call is received. That embedded module will display somebody is calling. Right, that you have to test. Right. So there are interfaces using that by writing some code in Python that will drive the mobile. That means it will they will have a SIM connected to that hardware that will make a call to a particular number, particular number which is in your embedded module. With that, it is associated. When that call is coming, actually, it is not a actual call made by another person. The software is making the call via the test boxes and other interfaces, the customized interfaces that they developed. Right. In that time, actually, the program they will do manual verification as well. There will be a testing engineer after executing that programming Python script, which is making a call to that embedded module. He will verify whether the call that is so and so is calling is displaying properly in the embedded module or not. He may get a prompt. Moment he acknowledge that, it will put pass to that test. Like that, every embedded module should we can automate the test, but it will be a customized solution written using Python, written using C sharp, written using Java. Like that, they can use JavaScript. Like that, they may choose some programming language and will do the testing if it is a test automation related stuff. If it is simply a manual testing, they will do a manual testing only, signal verification and uh, visual inspections. They used to have a procedures, manual test procedure. Using that, they will test and will put pass or fail. When you come to bus system testing, the CAN standard testing, Lin standards testing, in that case only we require this Kano, these sort of tools.
okay. And in Python, using Python automation, we used to write that Python code and interface with the other hardware through USB. So later it will do all that. That's it, no?
Yeah,
Oh,
let us say tomorrow I am developing a instrument cluster for using PIC microcontroller. I have a instrument cluster in my place. Now I have to test this using Python. I don't have Kano. How I will do? First thing is I should have a system which can produce CAN signal input to, let us say my product doesn't have any CAN signal input, all are hardware input. I have to turn on a LED now in my module, electronic module. Let us say that module will get the state of LED using a UART communication. It will receive the status. If there is a bit set in that byte, it will turn on that check engine tell type. This is the let us say use case. So I have a developed embedded module. It doesn't use any CAN message for transmission. It is receiving the state of the bulb using a RS-232 USART communication. How can I test this using Python? Can I test using this Python if that module is developed? Yes, you can do. What you need, because there is a library available for USART communication, I will just import that library. Okay, after importing it, I have to give a RS-232 packet to that embedded module. So I will configure. serial port, USART port in Python itself. For that also the library is available. I will enable them. After that, I will send the byte that they want to receive from PC or from other module to turn on the bulb. I will send it from PC so that my USB to RS-232 converter will convert that value to will receive my value from the Python script that I am executing from laptop to the embedded module. The moment the byte is received by the embedded module from the PC, it will react to it. It will turn on the bulb as we do for CAN. Let us say I have to give a what is a or digital input, active high or active low. I can use a relay. There are libraries available which can access the uh, IO cards uh, right now from Python. By driving that IO card, I can make that relay to turn on. When the relay is turned on, I can give that input to my embedded module. So when I give input to that relay, which in turn controls my electronic module. If the electronic module is giving some reaction, I can verify that manually. If there is a signal to be verified, I can use another DAC card to digitize it. For that, this DAC cards of stuff, there is a tool as well, LabVIEW, those things, the ready-made tools, which can easily interface with any IO cards and can drive any digital IO port. So it's not a rocket science that we have to go only for LabVIEW. We can do that using a C programming itself. Using a GCC compiler itself, we can do a test automation. But thing is, you require a programming skill and then interfacing skill and how to make the selection, what to use for what. That needed experience.
Now I got an idea how they will test.
Right now.
Yeah.
It is not like there will be some tool in the market, they will buy it and will do that. They are depends on, yes, there are tools. It's MATLAB, LabVIEW, they are there, but they are pricey. They have, if the product is very big, they will go for these sort of tools. Those were available in the market readily. It is they can develop their own customized tools as well. This is how the embedded testing is going on. They will do manual testing, some 40% remaining they can use some sort of ready-made tool or they can develop their own tool
Yeah, answer. Now it's clear.
right now.
Yeah.
Okay, let me catch you tomorrow to discuss further.
Yeah. Thank you.